Now let's look at user management within Debian Linux version 6. So via the tools that are presented, we're able to create, modify, remove users and groups. Users are the essential component of a system that interact, or the essential subject of a system that interacts with or interact with objects on the system, such as files. In Linux and Unix, everything's a file, and subjects like users interact with those files, whether directories, compressed files, name pipes, sockets, you name it. Subjects and objects are constantly communicating. So facilitates subject-object communication. And in a Linux realm, this simply means that the subjects are basically users who may be grouped, and objects are files. And of course, files can be files, directories, named pipes, sockets, etc. So, in order to take advantage of the resources provided by Linux, you need an account. And of course, from a security perspective, auditing does not occur without segregating users into distinct accounts. So it's not a good idea generally to have users share credentials. So each user should have their own account. Now, in Debian Linux, users are seeded at UID 1000. So users are seeded or indexed at UID/GID 1000. This is the default configuration. System accounts range from 0, which of course is the reserved UID, and GID. So system accounts, let's just note, UID/GIDs range from 0, which is of course for root, up to, but not including, 1000. So 0 through 999 for the various accounts like daemon accounts and FTP and all of the other accounts that are important to operate your system, admin, etc. Now, accounts by default are defined in etc password, and passwords are stored in etc shadow by default. If you authenticate to a different source, such as an LDAP-based source like Active Directory or standard Linux, Unix LDAP, then your subjects will be defined, users and groups will be defined in those repositories. But by default, when you set up your system, unless you change the authentication scheme, you can find the users in etc password and the passwords in etc shadow and groups in etc group. So, with that said, how do we define new groups, users, etc.? Well, let's set up some tasks. First, let's explore the current configuration, beginning with etc password. Any user may interact with etc password, so its permissions are set to be 644 or read, write, read, read. That means we can take a look at it as a non-privileged user. Notice the first account created is root. And the syntax of this file is rather straightforward. It includes a number of key fields, including but not limited to the following. Let's go ahead and paste this in, and that should probably did not copy. And etc password per user contains this sort of layout, which includes a name of the user, followed by X to reference the fact that the password is to be obtained from the shadow file, followed by the UID, the GID, the description, the user's home directory, and the user's shell. So in a nutshell, name, that's the account name used by the user to log in, shadow reference, UID, GID, description, the home directory, and the shell. By the way, as we've mentioned, there is a variable called shell. If we echo shell it reveals the current shell, bin bash in this case. That's why we use the variables. And if you echo, for example, home, it reveals the user's home directory. So whenever you see a $ followed by, in particular with a caps related item, it's a variable that's interpolated by the shell bash. So this is a standard etc password file as it refers to various users. Now let's take a look at the file yet again. So the first user defined is root, indexed at UID 0 and GID 0. And then there are accounts to run your system. Daemon, for example, bin, games, www-data for Apache, and others. And they all lead up to the first defined user during the installation, that is. That's the user Linux CBT. So system accounts and the root privilege account range from 0 through 999. We see an account here for SSHD, so the daemon SSH uses this account with a UID of 106 and the anonymous GID of 655534 or 65534. So the first indexed normal subject or user is Linux CBT, defined during installation as UID 1000 and GID 1000 with various attributes concerning home directory, shell, etc. So let's take a look at this entry, and we see that the description is Linux CBT user, and there are some commas which will allow the system to resolve other information, such as, let's say, department office phone number. It's usually operating system dependent or distribution dependent what the labels reference, but the comma denotes those additional fields which are set blank for this user. So each UID wears the same GID by default. This can be changed. Users can be grouped to a common GID such as 100, for example, but the default behavior is this user principal scheme where users have their own groups. So that's etc password. etc shadow contains mappings per user with the appropriate passwords. So that file, however, if we etc shadow, you'll note we are not able to interact with. Only root and members of the shadow group may interact with the file. So we need to su in, because it contains the encrypted string that correlates to each user's password. So here's etc shadow. Here is the string that constitutes root's password. And if you notice, the string appears to be identical to the string for the other user, Linux CBT. It starts off with $6i, but it's not. It differs. So this is the encrypted password that's resolved on the fly when the user attempts to authenticate. The system accounts do not have passwords associated because they do not need to obtain a TTY or a shell. They run in the background with various UID and GID privileges. There are some important fields that are spelled out in the shadow file. Let's take an entry, for example. Let's take the entry for Linux CBT, which spills over a line because of the length of the password. That's one of the issues surrounding the longer encryption mechanisms. So B etc shadow. This is the password database. So what are the important fields in this particular file as they're spelled out and used for authenticating users on the system? Well, in the first field there's a mapping, a one-to-one mapping of the username. So notice in the one-to-one mapping to etc password. Notice in etc password the first field contains the username. So it's the same here. So the fields of etc shadow include username or login name. That's the first field, followed by the encrypted password. So that is this long string, and the delimiter is a colon, followed by the days since the Unix epoch that the password was last changed. So days since Unix epoch password was changed, followed by the days before the password may be changed. So days before password may be changed, and that's the field between 15090 and this one, and 9999. So that's the days before the password may be changed, which is set to 0, which means the user can change the password at any time. The user need not hold on to the password for a set number of days before having to change it, which in and of itself isn't as tight as it could be. But nonetheless, that is the default setting that's applied to newly created users. Followed by the days after which, this 99999, days after which the password must be changed. In other words, the length of time that the user may hold on to the password. So maximum password age, if you will. Followed by an item, which is currently 7 by default, which reflects the days before the password is going to expire that the user is warned. So it's a warning. So warning prior to expiration. At least the user will be given a full week to have an opportunity to reset the password. Followed by a couple other fields which are currently undefined for this user and not used, but nonetheless are useful when defined. So days after, or days before password is set to expire that the user is warned, then days after password expires that the account is disabled. So days after password expires that the account is disabled. It's default not enabled. Followed by the days since the Unix epoch that the account has been disabled. And the final field is simply a reserved field, so it's currently not used. These fields, if you use LDAP, have to be mapped out one-to-one so that the resolver knows what to do with them. So let's just break these out into separate lines in a single column so it's easier to parse visually. And these are the shadow fields that control the policy assigned to users of your NIX-based system. And this applies to basically all NIX-based systems. So there's a one-to-one mapping between etc shadow, the username, and etc password. And notice that it's tied based on login name and not by UID. So the names match up and then the relationship is spelled out. So there's some defaults that are defined, and what we will do next is actually define some users in a variety of methods. So let's set up as a separate task. Define new users. There are a number of ways in which you may define new users, either using GUI tools or shell-based tools, and there are a couple of shell options that you may use. Let's start with one of the most commonly found and used shell option across Linux distributions. That is the user add utility. The user add utility adds users to etc password, and it will also create an entry for them in etc shadow, but it doesn't set a password by default. It also does not by default create a user home directory, nor does it populate that home directory with some default files. So user add creates users, but does not auto create home with data. And that can be an issue. So let's take a look at how we'd implement user add. User add, for example, LCBT2, new user. So what does this do? Let's take a look at the shell. Of course, we need to be root, and we are. Let's reset this buffer. So let's user add LCBT2. Well, first and foremost, it needs to check that the user doesn't already exist. Notice it added the user without any complaints. Now let's try to re-add user add LCBT2. Notice it now knows that the user is there, so it complains. So it doesn't do it twice. Now, when we tail etc password at this stage, you'll see LCBT2 has been assigned the UID and GID that's one up from the previously defined user. So user add does that for us. It also by default indicates where the user's home directory should be, and it sets a default shell as per the system policy, in this case of the Bourne shell. However, let's take a look at /home and notice that the sole directory is the one that corresponds to the user that was created during installation. That's for LCBT. And that's because user add does not create the directory for the user, nor does it set a password. Let's tail etc shadow to see what has been set up. Notice an entry has been created for the user, but no password. The second field contains an exclamation mark, which means the password is not yet set. So UserAdd may be useful in the event that you're wondering, well, why use UserAdd? Well, you may use it from scripts, for example, where you want to control each step of the user creation process, meaning creating the user, setting the password, populating the directory with sample data, and so on. So UserAdd creates this trace. Let's take the trace from etc password as well. It increments the UID GID for the user, which is fine, but it doesn't do all of what we need to get the user up and running. Meaning if we tried to SSH into the system or log in from a different shell, it would simply fail at this particular point. So LinuxCBT2 is defined with a UID of 1001, GID of 1001, and with default memberships to certain groups. Now that begs the question, can we SU in as LinuxCBT2 this newly created user? Certainly, because root can SU in as anyone. What is our current home directory? Well, if we cd nothing, it can't find home LinuxCBT2. The directory doesn't exist. Who am I? Well, we are LinuxCBT2. ID, well, here are our default groups. User principal and anything else that should be set, which is still just user principal group. So this user is not ready to use the system. The user cannot log in. If we try to log in, for example, which is one of the options that's available using new login in a window, this brings up a separate window within our window. And if we try to log in as LinuxCBT2, well, one, we don't have a password, so it's not going to work. So even if we tried blank, it doesn't let us in. And let's try, let's say, a password that we have set for LinuxCBT. It doesn't let us in, so we can't get in. Let's close this out. And then let's drop the shell. Now the way to rectify this is to set a password using password. So with this method, what we want to do here is define a password for the user using the password program. So password LinuxCBT2 will allow us to set a password. So password LinuxCBT2. Now we can define a password for the user, but we still do not have a home directory. Let's just try it again. We didn't specify it correctly for that user, so that's still a problem. And again, we missed duplicating the password correctly. Now it's successful. So now, if we tail etc password, or etc shadow that is, we should see that the user's password string has been updated, and that's fine. But the user still has no home directory. So the next step when using UserAdd, especially if you're scripting this out, is to make a directory /home username LinuxCBT2. But that's not enough. You should also change the permissions on it such that the user owns it. So if we take a look, lsld, for example, home directory of LinuxCBT, for example, notice that it's owned by the user and the group. So we want to follow similarly using the chown command, for example. So change ownership LinuxCBT, or LinuxCBT2 in this particular case, and that's going to be for ~LinuxCBT2. Tilde simply means shortcut to the user's home directory. And if that goes well, let's just ensure that we echo the exit status to tell us whether or not the chown worked as expected. So let's try this out. And it apparently, ostensibly, was successful. Now let's lsld again, LinuxCBT2. And indeed, the permissions have been set because we used chown to set the permissions accordingly. However, there's still some issues. By creating the directory, a skeleton of files that is standard operation for creating new Linux users have not been copied to the user's directory. So let's lsl, let's even lsla to show hidden items LinuxCBT2. And notice the directory is empty. Whereas for other defined users, a skeleton is copied. A skeleton of items can be found in etc_skel. These are items that should be copied to each user's home directory. So that means we need to copy these items. Let's copy etc_skel* to LinuxCBT2. And that way, let's go ahead and just copy the hidden items. The user will have those entries. And also, let's just check the permissions of LinuxCBT2 to make sure that the permissions are propos. So we want to chown LinuxCBT, and that's LinuxCBT2, all of the items. to be sure that the user can write to the files, meaning read the files, and in this case they don't need to write to bash logout bash rc, but nonetheless, if the user wanted to write to his own config files for logging out as well as for runtime variables. So now the user has a proper environment, which means we can SSH in. So we've made the directory, and let's just include as a separate step that we have copied etc_skel.star, because they're hidden, to ~linuxcbt2, and we've also followed that up with a chown linuxcbt, which is not necessary, but if the user wants to be able to make changes, will become necessary. So let's just include that we've done this, linuxcbt2.star, to set the permissions accordingly. So all of these steps, which could be avoided if we simply use the GUI tool or some other mechanism. So let's see what happens now. If we try to log in again, using a new login in a new window, as linuxcbt2 with an appropriate password, this is going to set up the environment for us and give us a little desktop to work with. So now the user has a proper environment, and now user has a home directory, and here are some items that have been populated for the user. That means if we take a look from the shell, LSL, linuxcbt2, we should see a slew of new directories and entries. And if we turn on the A option, we should see all of the GNOME or GNOME desktop environment manage items. So this user can actually log in accordingly. Let's remove this from the panel so that this is all timeless. So here is another session using Zephyr. And in fact, we can log out linuxcbt2 because we no longer need this session. But that's all arduous. So the simpler means of setting up users from the shell is to define new users using add user, which is a modification on user add. So define new user with user add. This is a traditional user add tool which you'll find across Linux and Unix distributions. So define new user using add user. Add user is rather simple. Add user, name of user, linuxcbt3. Let's see what happens when we run through this process as it's scripted, so it makes our lives much easier and much more streamlined. But again, there is an argument, there are multiple arguments, perhaps arguably, to use user add, especially in a scripted sense. I've used user add many times in scripts to save or to be able to control each step of the creation process of the user account, the subject, as opposed to add user, which is a script. Now let's do a which add user. It's in user sbin, so it's a tool that's available to super users. Let's go ahead and add user. Notice it walks us through a script. It knows that it's to assign 1002 as both UIDs and GIDs to the user because it's the next one up. And it'll create the user based on the name indicated. It'll also create a home directory and copy files from etc_skel, and it prompts us on standard in for a password for the user, for which it'll generate the appropriate string, and it prompts us for a full name as well. So linuxcbt user, let's give it a room number of 101 and a work phone of 888. These are the additional fields that we mentioned that's distribution specific insofar as what they store. And let's give it a home number of not applicable. Let's give it the same home number, or let's give it our fax number, 604-8028, and other, none. Is this correct? The script walks through the process, echo the exit status, and now if we examine the contents of linuxcbt, first let's take a look at the top level directory of linuxcbt3. Notice that the permissions are flagged accordingly. 755, owned by linuxcbt3, both UID and GID. Then let's take a look at the directory. And notice it shows empty. Now let's turn on the hidden files. And there we see the hidden files, and they're flagged appropriately as we've done manually using chown. So this is taken care of for us. Additionally, let's tail etc password, and you'll see that the user has been entered appropriately with the appropriate UID, GID, and with the fields spelled out for the room, office phone, home phone, which we put as a fax number, and additional information. Those are the comma delimiters that we indicated before. And home directory as well as default shell, which is set to bin bash as opposed to bourne shell. So the user is properly set up in this case, which means if we now try to log in, of course, let's go to our new login in a window, and you'll see this additional user on the list, LinuxCBT. In fact, they're aliased out as the name, so we should update that name using user mod, for example. And let's go ahead and pick this one and create a new session. While that creates a session, this gives us an opportunity to use user mod. If you use user mod, you can indicate the field that you'd like to influence, such as the description that's associated with a given user. You can write the description to be something that's more unique, such as, let's do a tail etc password, for example. So we take a look at this particular entry. The comment is this field. So if we user mod, and that's, if you scroll up, we'll see that's the C option. That's the geckos field. LinuxCBT3. This is the field that we want to modify, but we didn't specify a comment. So we want a comment of LinuxCBT3 for that particular user. Now let's retail it. And notice it's been updated. Now if we included commas with the various fields that adduser prompted us for, then it would preserve those fields and it would be parsed accordingly with the GUI tool. So now the user is identified uniquely. And let's clean this up as well. This is the default GNOME desktop environment layout. Now let's log out of this session and create a new session, and you'll see that it now reflects the new geckos field information momentarily, as opposed to being confused with the other items. So here's LinuxCBT3, here's LinuxCBT user. So the geckos field is read by GNOME and displayed to us in that graphical interface. So using adduser saves us a lot of time, a lot of headache. And let's SU in as LinuxCBT3 and run ID. And we see the group information user principal, just like we saw with LinuxCBT2. But different shell, of course. To update the shell for the other user, user mod, shell, bin bash, LinuxCBT2, echo the exit status. If it's clean, let's SU in as LinuxCBT2, and now the shell is bash. So let's just note that we've also modified users. So modify user information with user mod. Invariably, you'll have to use this tool or a GUI equivalent. So user mod, shell bin bash, for example, LinuxCBT2 updates the user's shell to bin bash. And similarly, as we've performed, user mod comment field LinuxCBT3 for the user LinuxCBT3 updates the geckos or comment field to the value indicated, so that things are cleaned up a bit. So we've got user add, add user, and similarly we have group add as well, and group mod for adding groups. Now to simplify all of this, of course there's a graphical tool that we can use. In administration, if you take a look, this is the graphical equivalent users and groups, which allows us to manipulate the users and groups on the system. So here's the most recently created user. We can make changes to that user, account type, password, so on and so forth. Advanced settings, let's go ahead and authenticate. And this will give us access to additional fields. Here are the three fields we mentioned in the geckos field. Here are groups, additional groups, secondary groups that we can associate the user with. And here are fields from the password file. We can disable the account, which is really a shadow entry. We can change the home directory. We can change the shell to one of the other shells supported by the system. Sometimes you have to define users, for example, with bin false as a shell, or not have to, but should, so that the user never logs in, such as an FTP account, for example. The main group that user belongs to, and the user's ID. So those are fields that can be changed at any time. And here's some other options, such as the password, whether or not you'd like to change it, what you'd like to set it to, or have a random password generated on the fly for you. And here's some passwords that you could assign to the user or just cancel altogether. Change the account type. Is it custom or is it equivalent to administrator, which would confer additional privileges on the user, or a desktop user who can do things on the desktop, adding USB devices, so on and so forth. So user add is a simple tool. The GUI is rather self-explanatory. It also allows you, obviously, to manipulate groups as well. So you can manipulate a group, and When you click on the Manage Groups, it pulls it up in a separate window. Here are some default groups that are included which confer certain privileges. But you can add a group, give it a name once you authenticate. Some basic things. Remember, etc password is readable by everyone, so some basic information comes up by default. So you can define a new group, give it a new group ID. Perhaps you should make it an ID that doesn't conflict with the default UID GID scheme that's implemented by Debian, 1000 and up. So you should use a range of 0 through 999, for example, or a higher range like 50,000 through 60,000 or otherwise, so that they don't conflict. And then you can join those users to those groups and then assign those groups to privileges, let's say, for directory access or otherwise. So that's a little bit about creating users within the Debian GNU Linux environment. Add users simplifies the process altogether, and entirely the process is rather straightforward. It doesn't take much effort whatsoever. The fields are rather limited, and it is rather clean and easy to implement.